to read a DIALux report? Just a little bit of basic webinar protocol for anyone who's not familiar with Zoom. So everyone's muted apart from me and Marco. So if you have any questions, please put them into the Q&A section. And of course, say hello to us in the chat box, but keep questions to the Q&A. It just makes it much easier for us to answer them as we go along. And after the webinar, we'll send out an email with a link to the recording. So if anyone would like to rewatch anything or share with any of their colleagues, please feel free to do so. And any resources that we mentioned during the webinar as well will also be linked in that email. Once the webinar's over in your browser, a quick survey will pop up. It's just 4 questions. We'd love to know how you think we've done today. It should only take you 2 minutes, and we really appreciate any feedback you can give us. So first off, we'll do some introductions to our wonderful presenter, who you've probably already seen on the call today, and a little bit about Midstream Lighting for any of you that don't know who we are. And then we'll go into the main presentation where we're going to take a look at a DIALux report that's with an airport design, and we'll also cover the sports pitches, maritime terminals, and then our HM descriptions as well. And then we've got 15 minutes for questions at the end, but please ask as we go along, and if it makes sense, I'll interrupt Marco and ask the question then and there. So first off, my name's Sophie and I'm Head of Marketing here at Midstream Lighting, and I'm your host. And I'm very pleased to be joined by Marco Cavallotti. Marco, would you like to introduce yourself, please?
Oh, yes. Hello, everyone. I'm Marco. I'm the Head of Projects here at Midstream. I joined the company back in 2015, so it's been 10 years this year. I joined the company as a pure lighting designer, and within the years, I gathered, thanks to the company, the ability to complete lighting designs and to give the support on site. And I'm currently leading our team of engineers for all the lighting design. So I look after all the design from the beginning to the understanding of the goals, to the tailoring of the design, and then for the installation and commissioning support.
Wonderful. Thank you, Marco. And he's not done himself justice there. He really is an expert in all things lighting design. So the perfect person to take us through this presentation today. So for those of you who don't know us, we're Midstream Lighting. We're an LED lighting manufacturer and solutions provider. And we're really specialists, not generalists. And by that, I mean we make products and solutions only for our key sectors. So that's aviation, maritime, sports, and the military. And we offer a full turnkey solution. So we don't just make products, we do everything from obviously lighting design right at the beginning to helping you with your project planning, any consultation you may need, help with looking for funding, obviously manufacturing those products, shipping them out to you, installation, and we offer education as well to our customers. So that's why we're doing these webinars, to help our customers make the best choices for them. So Marco, over to you. We're going to dive straight into the presentation now.
Okay. Please, Sophie, let me know when you can see my screen.
Yep, all good. Thanks, Marco.
Okay, amazing. So we have decided to go through these DIALux reports for 3 verticals, for aviation, sports, and then maritime. Obviously, let's say the majority of the parts of the reports are shared between the verticals, but there are some small differences which we will show to you within these webinars. The lighting simulation is the direct output from the software. This means that it's a printout from the design software, which is DIALux, the one that we use. Obviously can be customized, but we found within the years like what we think is the best way to show either the lighting simulation, which is a complex and long document, and then all the relevant information in a single page document, which is our HIMARS description. So we can crack on and go with the lighting simulation. What you see on my screen is the direct output from the software. This is the cover page. It can be customized. So the information that you see here can be manually inserted by the designer. We don't want to, let's say, overload this page with too many information. So what we do is to simply summarize the quantity of iMust included in our outdoor lighting design, the total floodlights, the total power installed, and the maintenance factor. These are the most important information because the power, obviously, it's really important for your energy calculation. The quantity of luminaires is important because of the budget and stuff like that. And the infrastructure is the quantity of iMust and its height. So you can either check that the height is correct and that the number is correct.
Before we move on, for anyone who's wondering what the maintenance factor is, we did a wonderful webinar about a month ago on it. And I'll include a link in the email out. So you can watch that if you've got any questions about the maintenance factor and how we determine that.
Perfect. So we can move on. The first page, let's see, the second page on the cover is the table of content. This is an index of all the documents which are included in this report. We've got the project cover, table of content, then we got the data sheet of the luminaires, and then we got all the parts related to the design itself. Whatever is included in the exterior scene, which can be multiple. In our example, it's just one, but can be 2, 3 different scenarios, for example, with switching or control system dimming or stuff like that. And it is, let's say, the summary is here. So we got the planning data, partial list, layout plan, coordinate list, results overview of the calculation surfaces, and a couple of views for 3D visualization, let's say. Then, after all of these, which is, let's say, a small portion of the document, you have a dedicated pages for each of the calculation surface you're going to calculate inside the design. Obviously, this is just an example. We have done like a small design, but still, this document is a 41 pages, very detailed document, which it's important to understand how to read to gather all the information that you're looking for. We can move on. The first, let's say, part is the luminaire datasheet. This depends on the supplier. What you can see with our one is just a quick visualization of the photometric file. What you see on the right part of the screen, it's the photometric curve, and it is a side view, a cut side view of the light distribution coming from the luminaire. Obviously, the photometric files is a 3D file because it's on 3 axes, but here it's just a visualization of the light distribution. It says the name of the product and the optic and some other information which can be included in the photometric file.
Marco, before we move on, due to missing symmetry properties, no UGLR table can be displayed. Can you just explain what that means, please?
Yes, this again, it's just let's say visualization. The UGR table can be seen with the photometric files with the dedicated software. Obviously, again, this is a 2D visualization. To see the UGR table, you need to have a dedicated software. In case you need our photometric files, they're always available. You just need to ask for them. They are not in our website or in other platforms just because we constantly update our product with new beams of LEDs, new optics, or new accessories. So we just want to give to customer or designers or consultants the most up-to-date photometric files. This is really important because with the not up-to-date photometric files, you can maybe have not the highest efficiency or not the most up-to-date curve. These will translate in a design which is not exactly what you are going to have on site with our product. So we do prefer to send it after a request. So the design team, myself, and our technical team can check that the data is the most up-to-date one.
Thanks, Marco.
After that, we got the planning data. This is a really important page in a report. From our point of view as a designer, when we receive a design, just a report of a design. This is one of the main pages we focus on. You have a general distribution of the area with the position of the high mast, position of the surfaces. This is just obviously visual, but you have an understanding of what you're going to do. Then you have the maintenance factor, which is directly from the software. So this is exactly what you will have, whether on the cover page, maybe being a handmade part can include a typo. This is exactly what it's included in the software. This is a ULR, the upward light ratio, very important parameter. It's a portion of the light which is emitted above the horizon. So it's either, let's say, wasted light, which is not hitting the target area, or is creating light pollution and glare.
Marco, sorry, we just had a question. What are the arrows? What do they signify?
Okay, these arrows, for this specific design, this is an airport compliant with ICAO regulation. ICAO prescribes two different calculation surfaces for the aircraft stands. One is on the horizontal plane at ground level, the other one is on the vertical plane at 2 meter high in relevant directions. This is what the norm says. When you have relevant direction, it depends on the designer and on the infrastructure to decide which direction is relevant. In this case, the relevant direction is towards the head of stand. So these arrows represent the direction of the vertical surfaces, which we are going to calculate in this report.
Brilliant, thank you.
Yeah, this means that the viewer, for example, is pointing his eyes towards that arrow. So it's 90-degree vertical surface. We got the luminaire partial list. So it's just one type of luminaire, one product with one optic. In case the design includes multiple product or multiple optic or multiple options, you will have 1, 2, 3, 4, 5 all listed. We got the name. This is the commercial name of our luminaires. This is included in the photometric files. It's the data that you can modify. Other supplier may have a code. We decide to use the commercial name because it's much easier to recognize which product are you using instead of maybe having a code which is just for production for technical people. Then you have the luminaires.
Sorry, Marco, just before we move on, can you just explain what the correction factor is as well, please?
Okay, the correction factor is what you will have. It's the difference between the net and gross lumen output. Here we got the luminaire, lumen, and lamps luminaire, lumen. It is, let's say, the lumen output of the lamp itself. So the product without any accessory or lenses, without a nettable, I mean, without considering all the light loss for optics or visors or accessories. And then you got the net lumen output, which is at net of all the losses, light losses because of the lenses or visor. This is the correction factor. Why our one is 1? It's because we take our product complete of all accessories or optic or secondary optic lenses, glass, screens, and stuff like that, or bracket, to the photometry lab to get a photometric file report back. So in case, for example, one luminaire is equipped with, I don't know, a symmetric optic, we have the photometric file tested on the lab without and with the visor. There's a difference, obviously, because the visor added like a light loss, for example, about 7%. So we prefer to have a photometric file which is already exactly as the final product which will be installed, instead of adding a correction factor. So that's the reason why our one is 1. Usually it can be, I don't know, 0.95 or 0.80 according to the light loss that you have. This also covers this little section of this page, and then we got the power. So the power installed for a single luminaire, and then the total in terms of lumen, heat in the ground, and total power installed. Our new MR07, master MR07 is a 795 watt luminaires. For this project, the overall power is 22 kilowatts. If we move on, we got the luminaire partial list. This is just another little summary, which includes the basic information. So we know that we have 28 pieces of this product, which is the master MR7. We got, again, the lumen output, sorry, the lumen output net and gross, the luminaire wattage, the classification according to CIE. This is a standard. The CIE flux code is the portion of the light emitted at a certain angle, so 33% at 33 degrees, 82% at 82, and so on. This is just a standard. And then you have the classification of the photometry. This comes directly from the lab. You cannot modify it. So you are sure that the photometric file included in the design has not been manually changed. In case you see a star after the correction factor, it means that it's been manually changed inside DIALux software by the designer. So you should gather the information on why it has been modified. Maybe it has a higher or lower output or different power. Sorry. Then we got the layout plan of the luminaires. So where the luminaires are inside our design, you got a label with 1 here, and then you see that 1, 1, 1, 1, 1, and so on. We got 28 pieces, so you know where they are with the coordinates. I understand that it's not very clear. This is the reason why we have created an additional document to be attached to this report in order to understand exactly the position of luminaires and calculation surfaces.
Marco, sorry, can I ask you a question before we move on? So if there were different luminaires, would they have different numbers there? Would there be like a number 2, a number 3, for example, for different products?
Exactly. So just in case, for example, this is IMAST 1, and with this type of luminaires, we will have another label saying 2. How many pieces? I don't know, 10 pieces of the master MR15, for example, which is a different product. And then you will have number 2 here showed, so you know where the product is installed.
Great, thank you.
On the plan. If we move on, we got the coordinate list. This is another important part for us as a designer, but also for you. This is the position of each individual luminaires, not each high mast. So also over the high mast, you have the position. Coordinate is X, Y, and Z. X, Y refers to the 000 coordinate of the design inside the software. Can be confusing, so I would discard, let's say, this information because it's really depending on where the designer has placed the background, the CAD file in background on the design. It's important to know the Z coordinate because it's the height or where the luminaires are installed. So here, for example, you can check the height of the high mast, the installation height. In this case, this example, all the high masts are 30 meters. Then, so this is the position, X, Y, and Z, and this is the rotation of each individual luminaire. Still, X, Y, and Z. The X angle is always 0 because obviously the luminaire is fixed, so it has one fixed axis, which is the one of the brackets, so cannot move in this direction, cannot basculate. You can only increase the tilt and the rotation. You can change the rotation. So only Y, which is the tilt angle, and Z, which is the rotation angle. The tilt is important. Sometimes it has a limitation due to some norms or local authority request. This case, for example, the luminaires are tilted at 15 degrees. You see -15 here, only because the software considers counterclockwise rotation as negative. It depends on the photometric files. Sometimes it's positive, sometimes it's negative. You need to have an expert or the designer which has worked on the design to explain you this. Because of this, when we're going to install our luminaires, we do produce another handmade document, which is the mounting instructions, which include like side view of the luminaires, very detailed document with the angles, orientation, and tilting of the luminaires. But here, let's say you can have a general overview of how much the luminaires are tilted and the installation height. This applies to all the 28 luminaires considered in this design. The following section is the results overview for the calculation surfaces. These include all the calculation surfaces that has been considered in the design. It's more than 1 page, it's 2 pages here, for example. This is the most important part of the report because to have an ICAO compliance here, you need to have a certain level of light, a certain level of uniformity over a specific calculation surface. So here you can see the values for each calculation surface considered. The designation is an input from the designer. What we do is to use a horizontal value to underline that it's on an horizontal surface, and then the name of the aircraft stand, stand 1, 2, 3, and so on. Let's take, for example, just the line 1. We got the name, which again has been typed by the designer. You have a different name for the surface, I don't know, general area or parking area or road. You can write this. Then you got the fixed part. This is output from the software. So it depends on the settings that you apply to the calculation surface. The type is horizontal. You have horizontal, vertical, and cylindrical, perpendicular. You got a different, like a full set of different settings for the surfaces. The grid is the density of points. In this case, it's 64 by 64, which is quite a lot. Obviously, it's a software, so it doesn't take any more time to calculate more points. It's better to have more. But the software can calculate the right amount of points in order to have a reliable value for the relevant levels that we're looking for: average, minimum, maximum, and uniform. Then we got the EAV, which is the average illumination level. It's in lux. Norm says for 20, we got 34. This is just an example. E is illumination level for the minimum illumination level, still in lux, which is 11. And then we got the maximum illumination level, which is 62. After this, we got the other 2 parameters, which are really important, which are the uniformity, 1A and B, or 1 and 2, depends on the standards. U0 that you see here is the minimum average ratio. For example, ICAO compliance asks for exceeding 0.25. We got 0.33, so way more. And then we got the minimum maximum uniformity ratio. This is a parameter which is not required for all of the outdoor lighting. Actually, most of the outdoor lighting only requires the U0, minimum average, and not the minimum maximum, which is required, for example, for sports application. A football pitch has a very detailed grid on which calculate all the lighting values, and it has a really fast transitions between the points, football player running or the ball running from one side to the other of the pitch. So also this parameter is important. For this aviation application, this is not required. You cannot avoid the software from print out or also this line. This is a results overview for all the surfaces. Let's go to, for example, the vertical surface, stand 1. It's a vertical surface rotated 90 degrees. Again, counterclockwise, so you go up 90 degrees, and then you have the values that we have seen just now. The design for this example has 4 standard code EF stand, and then it has some other Mars stand, which are multiple aircraft stands, so they can allow different type of planes to park over the same area. You got, in fact, For example, stand 5 is divided in stand 5, which is the main one for the A380 or the Boeing 747, for example. And then you got the right and the left parts, so 5R and 5L. All of this needs to be calculated, but it's on another topic, just to show you for this example. After the results overview page, we got the 3D visualization. This is just, let's say, aesthetically, so you know the material, the colors, you see the luminaires here, you have a general idea of the light distribution, and then you have the much more important one, which is the false color rendering. This one can give you a really good understanding of the light distribution over the area. You have the legend here. This is, it is in lux, it's written here, LX. And then you got, for example, ICAO requirement is for 20 lux average. So we use 20 as a maximum level. Whatever is in white is above this value. And then you can interpolate the values down to 0 in this standard color scale. So you go, for example, between orange and yellow, all it's in red is between 15 and 20. All is in orange is between 12.5 and 17.5, and so on until 0, which is the black part. For example, behind the luminaires, there's absolutely no light. Also, this view is set up by the designer. DIALux is a 3D CAD software base, so you can rotate the view and print out multiple views, for example. So in case you need more than just a single view, I don't know, maybe there's a building or something you want to see behind the building or from a different angle, just ask for this, we can provide it. There's no problem in providing more views. These are the standard could F stand. And these one on the right part are the Mars stand. You can see that more than one plane can be placed at a time. So one big or two small plane. The next section is the detail page for each individual calculation surface considered. It's really long. We are on page 13 and the document is 41 pages. It includes the same information that we have seen in the results overview, so in the summary, but here it's just in more detail. So you have the dimension, for example, of the calculation surface with the shape. So for example, this code F stand is 75 meters by 85. And then you have in lux the values for each individual point. Obviously, this is a A4 document, cannot include everything. In case you need all the values of the 64 by 64 grid, there's another page that can be printed in which the surface is divided in little squares. And the software can show you, let's say, for this single stand, it's additional 10 pages to see each of these 64 by 64 points grid value is. We don't think it's relevant because here you have more than enough points to understand the light distribution. In case it's needed, it can be printed without any issue. Here, you know that it's exterior scene one. Again, it's the main one. You know the name of the surface and then what you're looking at. So the value chart, value in lux, of the illumination, and it is on the horizontal plane. Down here, you got a visualization of where the calculation surface is located onto the plan. So it's on the left part, for example, this one. And then here you got the relevant lighting parameters. Average illumination level, minimum illumination level, maximum, and the two uniformities. So this is, let's say, it's a zoom on the surface with the same information that we have seen on the results overview summary. So the rest of the document is just each individual area seen in very big detail. These are the verticals. You see the arrows, which shows the direction. There are no other information included in this, which are not already included in the sample. I think that for the aviation, we have completed. Obviously, the last page is the last calculation surface. But still, this is a 41 pages document for just 7 stands. Think about to have an airport with, I don't know, 150 aircraft stands. This document is a 400, 500 pages. Moving, sorry, moving to the next one. It's sport. Again, most of the information are shared between the two different designs, but some of them are slightly different. So, for example, on the front page here, we add some additional, let's say, information, still the maintenance factor, the quantity and height of the poles, total luminaires, total power installed. And then for sports, we add the lighting requirement, being not just a single norm, let's say ICAO for aviation. This is a 200 lux average football pitch with the requirement of uniformity greater than 0.6. And then you got what we are providing. So the calculated values exceed 200 lux and have more than 0.6 uniformity minimum average ratio. In addition to this, we got the grid in which these values are calculated. So this is just for you when we deliver you the project to validate, let's say, the design with requirement and where and the calculation grid, which in sports is really relevant. Can be 180 lux with 0.5 uniformity, can be on a different grid. So on the first page, we just add these basics information. Table of content is exactly the same. Summary of what you are going to see in the document. Luminaire datasheet is the same. This is a different product. It's the Master MR16 with our asymmetric optic. Is slightly different. It's specific for sports. Low glare, low tilt luminaires. Here you got the planning data. DIALux includes some standards sport pitch, football, for example, or soccer if you're looking at from US. Hockey pitch, tennis courts. It has some standard things, so it's much easier for you to identify what you're looking during like scrolling this document. Planning data includes the same information, maintenance factor, ULR, and the number of luminaires with the flux and the total power installed. This is still the partial list, just a single type luminaire, so we only got this with the little image of the light distribution. Layout plan here, for example, for sports is a bit more clear because you got where you have these parkour circles, you got the luminaires and the high mast. For sports pitches, we use the 0, 0, 0 coordinate in the exact middle of the pitch. So, for example, here you know that this pole is located 13 meters on the left side of the center line, and it is 36 meters down from the center of the pitch. So in this case, it's not that hard to understand also the geometry of the pitch and the high mast. Following page is the coordinate list. Again, we got the position, the height, rotation, and tilt of the luminaires. For sports, there's an additional page which is this coordinated with arrows. The arrows are just the floodlight arrangement of the luminaires. Inside DIALux software, you can place the luminaires in different arrangement. There's a circle arrangement, for example, for the crown on a high mast, port application, aviation application. It's a rounded crown, so you can place the luminaires on a round. On sports, we use the floodlight arrangement, in which you can select with an arrow exactly the peak of the luminaire where you want for him to hit the surface of the pitch. So here, it's nice, you got arrows, you know exactly where the luminaires are pointing. it's really convenient and it's easy to understand, to be understood. Then we got the 3D visualization. Again, on DIALux, you can add the materials on the surface. Usually, is not very is not required because the software considers the minimum, let's say, reflection for the floor. But here, both for let's say from an aesthetic point of view, but also from a practical point of view of refraction, we have added the grass over the football pitch. We got the false color rendering again. The scale is different because the requirement is different. You have a 200 lux average requirement and 0.6 uniformity. So what we have done is to place the white with 200 lux. So whatever is white is exceeding this. And then you got the red, which is exactly 0.6 of the average illumination level. So whatever is in red is between 105 and 200 lux. This is the main difference between aviation and sports. In sports, we use calculation grids and not calculation surfaces. The grids can be tailored, meaning that each point can be moved and can overlap exactly what the norm asks. Whether on calculation surface, you can only type the number of points or the distance between points, but not the exact location of the reading point. For this example, the grid is 11 by 8 points. It's an in-step grid. You need to follow the FA guide to place it. But with the grid, again, you can tailor the position of each reading point. The visualization here is with this gray cross for each of the 11 by 8 grid points. Here you got the basics information of the grid. So the position is in 0, 0, 0, the center of the grid. The size is 95 by 60 because the pitch is 100 by 65, and this is an in-step grid. It has no rotation, and it is 11 by 8 points. And it is included in the soccer field sports application. The results overview, again, as before, is the most important part. You got the average illumination level, minimum illumination level, maximum illumination level, uniformity, minimum average, uniformity, minimum maximum. This is the most important part that you need to look at. This is exactly the results that you are going to expect with installation. After this, there are some other slight differences between aviation and sports. We got the ISO lines. So in addition to the false color rendering, we got this visualization. For example, the line, everything which is included between this light blue line and this gray or yellow line is between 200 and 250 lux. Whatever is outside this light blue line within the brown is between 200 and 150. This is a different way of visualization of the light distribution. This goes pairs, let's say, with this other visualization, which is simply with the solid hatch instead of the ISO lines. Then the last page is the value chart. This is really important because when you're going to do the commissioning for a sports pitch, you need to go and gather the values over the exact same points that are included in the document. So here, you know that when you are on the field in this specific point, you should have 192 lux. Actually, with maintenance factor and installation, the value should be slightly different, but you have an idea of the values that you need to go into report.
Marco, sorry to interrupt you when you're in a flow. We've just had a question. Is the distance between the points fixed by a norm or standard?
Yes, exactly. It's the FA guide, which has exactly the plan on where to put the points. So according to the dimension of the pitch, they are pretty standard. Usually they are 100 by 65 or 100 by 70. But for every dimension, you got the exact location. of the grid. For example, for a FA guide here, it is in step, so you don't have to calculate or measure the points on the outline. For FIFA or for like a higher level of illumination, this is a 200 lux. FIFA, for example, level A is 2000 lux, so it's 10 times more. You have the points on the lines, on the outer lines, goal line and side lines. So each sports pitch has its own regulation.
Thanks, Marco.
No problem. We're running out of time, so I will go really quickly over the ports. Ports and aviation and other, let's say, outdoor designs shares most of the part. Because if you are doing a lighting design for a parking area, for an airport, or for a port, let's say that calculation surface, high mast, all of these parameters are the same. You only change, obviously, the layout and the requirements. So for this example, we have added two types of luminaires. They are both MR15 model, but with two different optic, AS and GA. 10i mast, 35 meters, total power installed, and maintenance factor. Front page, cover page is the same. Table of contents still the same, exactly the same as sports and aviation. Here we got the data sheet, 2 pages because they are two different optics of the same luminaires. This is the GA, is our, let's say, symmetric optic with an asymmetric distribution. And then we got our AS optic again. We got the planning data. In addition to this, compared to the aviation, is that we have included in our design the container stacks. So they are objects, and they are in blue line here. So this is a container stack, which has been included in the design as a solid object. Partial planning data still has the maintenance factor, upward light ratio, and so on. And then you got the partial list. As you can see, it's 1 and 2 articles, the numbers, and then the data that we have seen before, lamps and luminaires, lumen output, and power. The difference having two different models is also here on the partial list. Here we got the Master MR15 AS optic, 45 pieces, and then we got the Master MR15 GA optic, in which we have 20 pieces. Here you have the partial list. You see they are labeled 1 and 2. It's not very clear here, but it's not due to the design, it's due to the software outputs. But here you can see 1 and overlapped a 2. This means that on the same high mast, you have both products. Whether on this high mast, you only have 1. I appreciate and understand that this is not clear. This is the reason why we do additional documents to be attached to this output. There's no other way to print out the layout plan for the luminaires. Coordinate list of the luminaires is the same, but it is divided into sections, 1 for each type of luminaires. This one covers the Master MR15 AS optic. Here you see, and so all of these 45 pieces refers only to this product. And then you have the Master MR15 GA optic. We only have 20 pieces. These are the 20 pieces with all the relevant rotation, position, and clarity. Results overview, obviously, is much shorter because for this port, we only have, this is just an example, but the key area and the terminal area. The terminal area, for example, considers the area between the stacks with the stacks in place. The requirement is with 50 lux. And here you can see that is all matched with the uniformity and the other relevant values. The requirement for ports, for example, is only on the horizontal plane. So you will only have horizontal type calculation surfaces. 3D visualization. Here we have added the water to understand where is the key, where are the ship-to-shore cranes, and stuff like that. It's a bit fancy, but also it's useful because you understand exactly where the edge of the birth is. And then again, the really important false color rendering visualization. Requirement was for 50 lux average, so the white is moved to 50 lux. Following the 3D rendering, we still have the table E, so the value chart of the two surfaces, relevant information, dimension, height of the surface, and again, individual values over the surfaces. I think that with the lighting simulation, we can close here. Just really quickly, I want to show you what we do to simplify the reading of the document. This is a 41 pages document. It's the lighting simulation for a really small airport. We do the IMAS description. Single page A3 can be printed out can be used during a meeting to do some sketches. It includes the relevant information, such as the luminary schedule here. Each high mast is labeled, the high mast 1, 2, 3, and so on. And here you have the table with height, type of luminaires, number, power, absorbed wattage of the entire luminaire, of the entire high mast, and then the power consumption, considering a 12-hour usage per day. So 4,380 hours per year. You got the labels also for the surfaces. This is aircraft stand 1, 2, 3, and so on. This Mars stand is stand 5. 5L is the small one here. 5R is the small one here. And here you got the calculated lighting values table, which summarize everything. Without, let's say, showing you maximum levels, which is not relevant, or minimum maximum uniformity, which is not relevant for this application. So you can check that all the values match your requirement. We do the same for sports. This is your football pitch, 8 poles, luminary schedule is the same. FA calculation grid is written in the title block, maintenance factor, and then a calculated lighted values table, which is slightly different, because maximum value, for example, is important and relevant for sports, so we include it here. You got like a little box here with the visualization of the luminaires proposed, some very basic information, dimensions, power, and flux. And the last one, which is for the port, terminal area, key area, a high mast with all the labels, position of the container stocks, and then again, luminary schedule, maintenance factor on the title block, and calculated lighting values table. I think that this should cover everything, except for obviously the many questions that you may have, which I'll be happy to reply to.
Wonderful. Thank you very much, Marco. That was really useful. The HM description, as Marco said, is just a very simple overview of the whole document. It's not something that everyone provides, but is something we do at Midstream, and is something you should request when working with other designers or companies, because it just breaks down that report much simpler. So now we're going to answer some questions. I've seen a few people popping them into the chat. If you could put them into the Q&A box, please, it just makes it a bit easier for us to filter through them. So, Marco, 1 second.
I've seen just the first one, Sophie, while you are okay.
Yes, please.
The one is from Andy Sanders, is, hi Marco, will you be showing their RGL glare calculation? We have done some dedicated webinars for glare. We decided not to show in here just because of time. You see that we are already running out of time. They will be shown in the report if requested. What the software do is to, for the designers to place an observer, set up some parameters like viewing sector, angles, and stuff like that. And then when you run the calculation, you will have a summary at the end of the report with the maximum values of the glare, which usually is a cap at 50, so it should not exceed 50. Again, we can do like a dedicated session for glare if needed.
Yeah, exactly. As Marco says, we have in the plans to do a webinar next month on glare, and we can certainly take into consideration the glare calculation and include that in the webinar. Thanks, Marco. So our next question is asking about the DIALux software you're using. Would the Evo, for example, give you the same type of report? Is there any difference between the different versions?
Yeah, there is a very different, actually, it's a very different software because DIALux Evo is implemented mainly for indoor lighting calculation. So it doesn't have a lot of the features that standard DIALux. We use the 4.13, which is the most up-to-date version, for outdoor lighting. For example, the floodlight arrangement. So the arrangement of the luminaires in which you can use arrows to point exactly where you want the peak of the light is not available on DIALux Evo. The symmetry point, for example, for a football pitch, where the 8 eye masts are in a symmetric position, you can only place one high mast and then use the symmetry function to move the arrows in a symmetric way. Is not available. There's no, for example, other arrangement specific for the outdoor, like a circle arrangement and stuff like that. So it's not really ideal for outdoor lighting design. It's a really good software, still same brand, but it's much more detailed for indoor lighting. So we at the moment, since they are still updating the standard DIALux, we prefer to stay with the 4.13 version of DIALux.
Okay, wonderful. Thank you very much. Our next question, is it possible to put shadows in the analysis because of the effect of objects, e.g. aircrafts?
Absolutely, yes. Sorry. For example, here in the port design, we have included the container stacks. Obviously, this is just a solid object, it's not the exact containers. This is due to the, there's no difference actually between a solid object or individual containers. The effect will be the same. But for the software, if you insert individual objects like containers multiple times, the calculation time for the lighting distribution will take forever. So we, let's say, simplify this with an object. And here you can see the shadows, for example. This part is a shadow, and you can see it also.
Marco,
here.
by the way, you're not sharing your screen. It's
Oh,
on mine.
clearly. Thank you, Sophie. Sorry.
That's all right.
Okay. So yes, again, sorry. We can include the 3D objects such as plane, buildings, or container stacked in display. In this case, here you can see the shadow. They consider a reflection. The software considers reflection, refractions, and stuff like that. And also on the 3D full color, you can see here that you have parts of this solid object, which are the container stack, which are in complete shadow. So the left side, for example, is 2.5 lux here. So we can definitely include 3D objects and shadows for our lighting design. Even if, for example, eye count for aviation requires those values with a clear stand. So no object of obstruction should be included in the design. Then, if you want to evaluate the shadowing, you can definitely do it.
Wonderful. I can see people still putting chat questions into the chat. If you can, please put them into the Q&A box. After the webinar, it just means any we haven't answered, we can download. If you put them into the chat box, I can't, don't worry, it's not a problem. Just if you can, it makes it a lot easier for us. And it just means that we can follow up with you directly if we haven't got time to answer it. But we have got time to answer, so we're going to answer a couple more questions. So first question, do you have a problem with reverse input numeric data in DIALux 4 in Windows 11? I hope you know what that means, Marco, because that's well over my head.
Do you have problems with the reverse input numeric data in DIALux 4? No, you need to, I mean, extend this question a bit more. Reverse input numeric data. What we do, I mean, I don't know if I'm replying correctly, but what we do, there's no relation between Windows and DIALux. I mean, they work with whatever Windows. I don't know what a reverse input numeric data is, but they work with photometric files, which is an IES format or LDT format. And this is the only input that you need to add into DIALux. So if you can extend the question, maybe I can reply in like in a bit more detail.
Yeah, so the person who's has asked anonymously, if you don't mind popping us an email, what we can do, Marco can follow up with you and answer in a bit more detail, just because we're not completely clear what you're asking. So let's just do one more question, because I'm sure people have got to move on for their other meetings and things. So last question is a bit of a controversial one. Would you consider lighting reality to be superior to DIALux, or are they quite similar? What would you recommend?
Okay, this is let's say it's a controversial question actually. Each software has its own users, let's say. We found that DIALux is really intuitive and it's the most worldwide diffused software. It's an open software and it's free. So if you want, for example, what we do is to do the lighting simulation for you, and then we can provide you with the open DIALux file format. So you can play around with it if you have people which knows how to use it. It's really quick in calculation and really reliable. Other softwares, I mean, we know how to read, obviously, the report also from other softwares. We went through, let's say, the majority of them, the most diffuse, but we think that DIALux is still one of the best because it's really user-friendly, can work with the CAD file, with the 3ds file. It's always updated. So my personal opinion is that for outdoor lighting, and specifically for our applications, is still the best software on the market right now. We also do some indoor lighting, for example, for hangars or for big warehouses, stuff like that, and it's worked really well as well for indoor. Still really light software, so can run also. You don't need like a workstation to use it. So this is also another good point. And also the output, I mean, in particular when you are navigating and doing the design, it's really, really good, in my opinion.
Wonderful, thank you. So that's all we've got time for today. We do have a couple of questions we haven't got round to answering, so we will follow up after the webinar to those of you who've asked them. And of course, if there's anything you haven't been able to ask today, you are more than welcome to email myself or Marco. Our email addresses are up on the screen now. Feel free to send us an email with any questions you've got around the report or anything else, and we'd be more than happy to answer them for you. But of course, a huge thank you to Marco today for presenting and for talking us through all of that. That was really interesting. And I hope all of you at home have also found that helpful. And of course, thank you guys as well for attending. We hope you found it useful.